So, what if I told you that the most important part of your next car isn't the physical car at all? What if it's a perfect, living, digital copy of it that exists entirely in the cloud? Today, we're diving deep into digital twin technology, and we're going to see how this ghost in the machine is completely flipping the script on how cars are designed, built, and even how they drive.
Okay, so here's the game plan. We'll start with why the old way of building cars is basically broken. Then, we'll properly meet the digital twin. We'll explore how it's making batteries safer and more powerful, how it tests for absolute disasters, and even how it outsmarts hackers. And then, we're going to land on a pretty wild idea about what a car even is anymore.
All right, first things first. Why did we need such a radical change in the first place? Well, the short answer is that the auto industry was heading for a crisis of complexity that had been building for years.
I mean, just think about it. A modern car isn't just an engine and wheels anymore, right? It's a supercomputer that you happen to sit in, running on millions, sometimes hundreds of millions of lines of code. And the old way of doing things, building tons of physical prototypes to test everything, is just way too slow, it's way too expensive. Frankly, it's hitting a brick wall.
And this really lays out the problem perfectly. You've got this clash of two worlds. The old way, you build a physical thing, and then you try to cram the software into it. But the new reality is that software is everything. It's constantly changing with over-the-air updates. The old process just can't keep up. You can't crash test 1,000 physical cars just to test one little software patch. There had to be a better way.
And that better way is the digital twin. Now, this isn't just a small step forward. It is a total revolution. It's about flipping the entire development process completely on its head with what they call a virtual-first approach.
So what exactly is a digital twin? Yeah, forget the idea of just a simple 3D model. The modern digital twin is a living, breathing virtual replica of the car. It's actually born before the physical car is even built. It lives alongside it its entire life, and it's constantly being fed data from the real world. You could almost think of it as the car's digital soul.
The secret weapon here, the whole strategy, is something called shift left. It's an engineering term, but the idea behind it is so simple and, frankly, brilliant. Instead of waiting around for physical parts to show up so you can test your software, you do almost all of it way up front, in the virtual world. You literally shift the entire testing schedule to the left, to the very beginning of the project timeline.
So here's a quick breakdown of how this actually works. Engineers create a virtual version of the car's main computer, the ECU, and they just run it in the cloud. Then they can test their actual production software on this virtual hardware. And the magic ingredient is bit parity, which just means the virtual version behaves exactly, bit for bit like the real chip will. So when the physical silicon finally gets delivered, the software works perfectly on day one because they've already got maybe 12 months of development in the bag. It's a massive, massive head start.
Okay, so let's see how this actually plays out in the real world. And let's start with the heart of any EV, the battery. This is where the digital twin stops being just a development tool and becomes more like a guardian angel.
So the battery digital twin, or BDT, uses this cool concept called cloud edge synergy. Just think of it like this. You have a medic right there in the car for instant responses, that's the edge, and you also have a whole team of specialists in a hospital analyzing data from everyone, that's the cloud. This lets it do incredible things, like predict the risk of a super dangerous thermal runaway event weeks before it could ever happen. It can also analyze data from the whole fleet of cars to learn the absolute best way to charge your specific battery.
And the results, they're totally tangible. By constantly optimizing everything, from charging cycles to power delivery, the digital twin can actively fight battery degradation. We're talking about extending its useful life by a very significant 7 to 10%. That could be years of extra driving for you. That's a huge deal.
And it's not just about performance either. The twin creates a digital battery passport, which tracks everything from the battery's carbon footprint to its manufacturing history. And this is not just some cool feature. It's actually becoming a legal requirement to meet strict EU regulations that are coming in 2027.
Okay, so beyond the battery, the digital twin's next big job is to prepare the car for the absolute chaos of the real world. This is especially true for advanced systems like autonomous driving.
You see, there's this huge problem, and some people call it the rarity curse. How in the world do you test for those 1 in a million catastrophic events? You can't just send a test driver into a blizzard and say, hey, go make the sensors fail. It is way too dangerous, it's unbelievably expensive, and you might have to wait years just for the right conditions to even happen.
And this is where the digital twin is just a total superhero. In the virtual world, you can summon that blizzard on demand. You can make the sensors fail. You can run that 1 in a million disaster scenario a million times over,
all safely from a computer, before you've even had your morning coffee. The power of this virtual testing it's just astounding. Think about the car's interior for a second. The screens, the buttons, the whole user experience. A staggering 80% of that can be fully tested, tweaked, and signed off on in a virtual simulation before a single piece of plastic has been molded or a screen has been ordered. The savings in time and money, they're astronomical.
So the twin helps build the car, and it makes it safe. But what about after it's on the road? In our crazy connected world, the next huge threat isn't a mechanical failure, it's a cyber attack. And here, the twin acts as the car's own personal bodyguard. You know, modern security systems are great, but they can generate thousands of alerts, and most of them are false alarms. This creates a huge problem called alert fatigue. It's like that one car alarm on your street that's always going off. After a while, you just start to ignore it.
But here's how the digital twin just cuts right through all that noise. It uses what's called a cyber-physical model. So it doesn't just see a command, it compares that command to the laws of physics in the real world. So for example, it gets a remote unlock command. Instead of just freaking out, it checks with its physical twin. It asks, hey, is the car moving? If the car's speed is greater than 0, well, it's physically impossible to unlock the doors that way. So it knows with 100% certainty this is an attack. It's using physics as the ultimate lie detector. So clever.
And all of this brings us to the final, and I think the most profound implication of this entire shift. We've seen how the digital twin helps design, test, protect, and improve the car. But what if we've been looking at this whole relationship completely wrong?
This quote from some industry analyst just reframes everything. The idea is that the digital twin, this perfect, upgradable, constantly learning virtual thing, is the real product. The physical car you drive is just a copy, an instance of that master product. This opens up totally new business models, where the real value comes from ongoing software updates to that master twin, maybe through a subscription.
And that leaves us with a really fascinating question for the future, doesn't it? As these digital twins become more and more central to our car's identity and its performance and its security, it forces us to really reconsider what ownership even means. If the physical car in your driveway is just an instance, just a copy, who really owns the original?